Hey, these are some introductory problems, and I've already received some questions about it. Even though we're going to go over it in class, I thought that I'd work through these problems, post the video, and maybe if you're still working on it tonight, it'll help you out. Otherwise, it might just make you feel better that you did it well or help you out in case you didn't. So the first problem says, if you are driving 95 kilometers per hour along a straight road and you look to the side for 2 seconds, how far do you travel during this inattentive period? So the first thing that I want to note is this question is asking how far. In other words, this question will be answered with x, x being a distance. Now, the equation that is solved for x would be equal to the average velocity times the time traveled plus the initial distance. Now, since this question doesn't give you an initial position and ask for a final position, really it's asking for how far you traveled. Maybe this equation would be better thought of like this. Subtract x sub 0 from both sides. This thing right there was the delta x. And if you remember, this is really the how far of physics. Now, what I just did right there was a really complicated, physics genius thing, but that's not what's required of you. I'm trying to be really precise and professional with it. Here is a more common sense way to do it. We know that the question is how far, so maybe it would have just been easier to assume x sub 0 equals 0 and just forget it. That means that the only equation we're really looking at here is x equals average velocity times time. And in fact, if you look at the question specifically, it says you are driving 95 kilometers per hour. In other words, forget average velocity. The question is telling you you're traveling at a constant velocity. So we can just forget about this and just let the equation, actually no, it looks like it has a bunch of hair. Let me write it one more time. It just boils down to this. Now, if you remember in class, I described this equation, which at the time was written in this form, solved for v, as the 9th grade version of the equation because it's so much simpler. Whereas this original complicated one is more mathematically sophisticated. This is able to handle more complex problems than the one this is asking. This problem is only so complicated that this one can handle it. So as long as you can do math with this one, but you're able to read that one, you're going to be in good shape. But we've got a problem to solve, so let's solve it. I've got an equation with x, v, and t. I'm being asked for x, so it has to give me v, and it has to give me t. So what are they? Starting over here, so I can work vertically. X equals vt. According to the problem, v equals 95 kilometers per hour, and the time is 2 seconds. You'll note that both of them are given with 2 significant digits. Well, the first most obvious thing you might think to do is, let me just substitute 95 in for v and 2.0 in for t. If you did that though, you'll end up with the wrong number because the units don't agree. Here's how it would look fully written out like that. The V is 95 kilometers per hour. And then you multiply that by 2.0 seconds, and just to make it a fraction, we'll put it over 1. Well, the question is asking how far, which means the answer will be in kilometers. But hours and seconds won't cancel out. So in order to fix that, we can just convert 2 seconds into hours. And we can do that by just putting in a conversion factor here with seconds on the bottom, hours on the top, just to make sure that you don't get thrown off with the clutter off to the side. Let me just zoom in on that real quick. 1 hour is equal to 3,600 seconds. So if you work out the math on that, you're looking at 95 times 2 divided by 3,600. That's a lot of digits. That has 2 significant digits. That has 2 significant digits. That is exact. It's infinitely precise. So I just need to round this to have 2 significant digits. And 2 significant digits on this would be right there. That 2 needs to round up to a 3, so it's 0.053 kilometers. .053 kilometers. There's your answer. All right. Now that took a really long time because included in me calculating the answer, I also gave this whole mini lecture on this equation and its usefulness for this problem. Once you get used to the equations, all of this is gone. And once the conversions become second nature to you, this becomes automatic, and this becomes the easy problem that it really is. Let's do the second one, and this time it won't take so long because I'm not going to overteach it. Number 2 asks, what must your car's average speed be in order to travel 235 kilometers in 2.75 hours? Now I could write the full version of the equation. Or I could write the nerfed version of the equation. Either way, there's not much of a difference between them because of the simplicity of the problem. It says 235 kilometers is what you travel. In other words, from start to finish, the change in location is 235 kilometers. No matter which one of these you use, it means the same thing. X or delta x, it's going to be 235 kilometers. As for delta t, it's 2.75 hours. Whether it's t or delta t, 2.75 hours. Again, the difference between t and delta t or x and delta x is going to be very specific to certain complicated problems. I don't want to have you start with this one and then find other problems too complicated, and so we need to get this. We're going to start with this, and then whenever it's appropriate, we will simplify it to that. That's the order that we're going to go in. Well, this isn't so complicated. We just need to put that in there. And that in there. 235 kilometers per 2.75 hours. I'm going to go ahead and just do that. It's not so hard. 235 divided by 2.75. There we go. 85.45 repeating. That's 3 digits. So that's going to be 85.5. Kilometers per out of frame. kilometers per hour. You could convert that to meters per second, but I'm not gonna, and neither should you. Number 3, a particle at, this picture is actually too small for me to read it. Hold on one sec. A particle at t1 is negative 2.0 seconds, is at x1 equals 4.8 centimeters, and at t2 equals 4.5 seconds, is at x2 equals 8.5 centimeters. Hold on just a second. That's a little complicated. Let's make sure we're clear on this. We're looking at a particle as it's traveling through space and through time. So you could kind of imagine that we've taken 2 pictures of it. Picture number 1 happens at time number 1, and it records it at place number 1. Picture number 2 happens at time 2 and records the particle in location 2. So this time 1 equals negative 2.0 seconds. Now, I said in class that we would rarely, if ever, have time be negative. Of course, you can have time be negative. The only reason to do that is to make a stupid, complicated physics problem for homework. I'll take that blame. I just took this from a textbook and wasn't paying attention. Negative 2.0 seconds just means, I don't know, it happened 2 seconds before midnight, and midnight is 0. Why not? And the location was 4.8 centimeters. So let me just see, look, there's a ruler, and there's the particle. See, it's moving. See, this is my cartoon skills. Right now, its location is 4.8 centimeters. See that? That's x1. But now move on to time 2. At time 2, we are looking at 4.5 seconds. Say, how long was that? You'd have to add those, or I'm sorry, you'd have to subtract them. I'm thinking subtract to minus is plus. So we've actually got a delta t of 6.5 seconds here. Anyway, where is it at t2? It's at 8.5 centimeters. So let's get that ruler. Now it's over here at 8.5 centimeters. And that is location 2. Get the idea? Back then, it was here. But later, it was here. We got a delta t, that would be time 2 minus time 1. It took 6 seconds for this to elapse to that. So how far did it go from here to there? Well, that would be 8.5 minus 4.8, which I could probably do in my head, but since I'm recording this, I'm going to avoid the embarrassment of making a mistake and having to correct myself. 8.5 minus 4.8 is 3.7. That would be a delta x. So we've got a delta t, we've got a delta x. I wonder if it's going to ask us for a v. What is its average velocity over this time interval? See, the equation average v equals delta x over delta t can be solved with a straightforward plugging in of numbers. X right there, t right there, and so it's going to be 3.7 over 6.5 centimeters per second. 3.7 over 6.5 gives us that number, two significant digits gives us 0.57. I can totally write sevens, I promise. 0.57 centimeters per second. Okay, so that's all the question was asking for. What is the average velocity? Of course, it also adds, can you calculate its average speed from these data? Well, of course I can. I just did. Why or why not? It's because x and t are the only terms needed to calculate value. Second to last one, a rolling ball moves from x1 equals 8.4 centimeters, x2 equals negative 4.2 centimeters during the time from, and it gives 2 times. What is the average velocity over this time interval? That's the same problem as this one, just with different numbers. So if you can do this one, you can do that one. Last of all, a bird can fly 25 kilometers per hour. How long does it take to fly 3.5 kilometers? So I didn't do that last one because this was so similar to this. And after all, I've got to save something for class. So let's do that last one. It's asking for t. Now, just as a reminder, when you solve those equations for t, you get this. Which is the complicated version. The simple version might look like this. As long as you understand that x may refer to the change in x and that a velocity may refer to an average velocity. Remember, this is just more precise. This is a better written sentence, you might say. This one is it's on a lower reading level, and this one might do sometimes, but when it fails us, we're going to regret it. So we like to try to stick to this whenever we can. A bird can fly 25 kilometers per hour. That's a v. How long does it take to fly 3.5 kilometers? That's an x. So let's substitute them. X on top, v on the bottom. This is just a job for a calculator right here. 3.5 divided by 25.14. 0.14 what? Hours. Now, just in case you need to see that worked out mathematically, why that's hours. First of all, why would you? It's asking how long. The unit is hours. Come on, it's the only time unit there. But just in case you need to see that worked out, if you do 3.5 kilometers divided by the fraction 25 kilometers per hour, you know the rule for dividing by fractions. You flip and multiply. So if you flip and multiply that, you end up with 35 kilometers times, now that's the top, 1 hour over 25 kilometers. So kilometers cancels. You're left with hours, and the math that I did was 35 divided by 25. So the unit is hours. Now, 0.14 hours is not usually how we refer to time. You might like to convert that to minutes or seconds. The problem didn't ask you to, so I wouldn't expect you to, but just in case you were inclined, 0.14, that's an H, believe me, hours times 3,600 seconds in 1 hour. I'm actually really curious. 504 seconds. Okay, maybe that wasn't the best conversion to do because I don't know how long 504 seconds is. I'm going to do that to minutes. 0.14 hours times 60 minutes over 1 hour. Let's do that one instead. 0.14 times 60, 8.4 minutes. That's better. 8.4 minutes. I'm a little curious. 0.4 minutes is 24 seconds. So it's 8 minutes and 24 seconds. All right, so 8 minutes, 24 seconds, but you know, you get the idea. Anyway, I really like when a class asks for help in so many numbers, so consistently. You might think all the students are asking for help. Oh no, it's a problem. No, it's not. You know what a problem is? Is someone who needs help and doesn't ask for it. Because the longer you don't ask for help, the more you feel like, well, I can't ask for help now because I didn't ask for it back then. And you just get stuck and behind and you freak out. And then all of a sudden, it all just comes down. And nobody wants that, especially not me, because it makes everything bad. Anyway, hopefully this is helpful. Of course it was, because this was your homework and you wanted help with it and you asked for it, and here it is. Video over now.